And again, hello, everyone. I'll be creating a new model. I'll be creating with the name workshop waffle. So this is my new model that I'll be starting from the scratch, and I'll be using this canvas here, this BeeGraphy canvas, as my whiteboard. So how I'll be doing this definition? The main goal is that we have like a structure, a waffle structure, and two directions. And for each direction, we have like the connection for each of them. So we have like something like this. For the other direction, we will have something like this. All of them connected, okay? But how we'll be starting this definition? So first of all, we'll need like a object that will be used as our geometry, so we can like create all of this structure in these two directions. So I'll be creating like a surface, a really simple surface, but I'll be creating from curves. So in one direction, I'll have like a curve like this or something. And then in this other end, I'll have like a surface, for example, straight. Then I'll be connecting them with the loft. And then the first step, which is the geometry that will be creating the waffle structure, will be done. So this is what I'll be doing first, okay? So how we can create this geometry, the surface, from couple lines. So we can use our friend loft surface. This component, we can give like an amount of curves, and then we will be creating like a surface going all of these curves through the sections, I may say. So this is what we'll be using. One of the inputs is the curve, so we'll be creating curves. There is a lot of methods of how we can create curves here in BeeGraphy. I'll be showing two of them for you guys. So the first one would be from points. We can have like some control points. For example, I can have a control point here, another one here, and another one here. Then we're going to interpolate a curve between them. That's the most forward solution of how we can like create curves. And then I'm going to show you a more automated one. So as I said, we need points. We can create points here using the construct point node in BeeGraphy. So for the construct point, we need like the three coordinates, X, Y, and Z. And we just need to input like a couple of numbers here. So I'll be using, for now, the number constant node, which I can like put some number here, and this number will be using as an input for this node. So for example, if I type the number 10 here, and then I connect this output in the X inputs, as you guys can see, my number, then it moved in the X direction. So here, my point, the coordinate in the X direction, it's 10. I can create another number constant for the Y. So for example, I can create like I can type the number 5 here, and then I can connect these inputs in the Y. As you guys can see, my number, it moved for the 5Y coordinate. And in the Z, I can also use my number constant node, and then I can give like a height, for example, 4. If I connect here to the Z, then as you guys can see, my point is now like in the 3D space. Okay, this is my first point, but as you guys can imagine, I can't create like a curve with only one point. I need to have at least 2 points. So what we can do, I can just copy these 4 nodes here, and then I can like copy them under here. The thing is that now I need to change these values here so we can create another point. In this moment, the 2 points, they lay in the same coordinates, so they are like on top of each other. So I'll be changing here a couple of coordinates, but the thing is, we need them to be lined up in this plane here. So I will not be changing the x coordinates, only the y and z coordinates. So for the y, I'll be putting like 10. As you guys can see now, my point, it has moved in the y direction. And for the z, I'll be putting like 2 or something. Okay. And just so we can keep the things like more clear in the definition, since we are not changing the x coordinates, we can use the same node here, and then we can take this output and put also in this node. So every time that I move, that I change this value, both of the points, they will still be like lined up in the same plane. Okay, I'll be putting this like 10. And we need like another point, because if I only have 2 points, I'll be only create like a polyline, a simple line actually. But since we are going to create our curve like more smooth, and we're going to interpolate the curve around these points, we need a third point. Then I'll be copying this again, and then I'll be changing these numbers here. I'll be putting like 20 maybe. Okay, and for the z, I'm gonna put like 5. Okay, so 5. Okay, so 5 here for this one, 10. Then it's 15. Let's make them equally spaced. Okay, so we got our 3 points here in these 3 nodes. Then now we can create a curve. I'll be using the NURBS curve component. Okay, the NURBS curve component, they do exactly what I showed you guys. I give like a list of points here, and then the curve will be interpolated between these points. So just a best practice, a good practice here in BeeGraphy. We can get all of these points, and then we can like just put them here. Okay. But the thing is, we can do this with like only in one component. For example, I can get this point here, I can get this point here, and then put it like right here, and this one, put it like right here. And as you guys can see, the curve is interpolated. But the thing is, this is not good when we get all of this output and then we go through the same input. The best practice is that we use a list merge, and then we merge all of our outputs in the same component so we can create a list. So how we can do this? I can just get the point. I go in to connect here at the list one. Then I'm gonna need another input, so I can just click on this input and add port. So this will be my second point. I'll need like a third one, so I'll be adding a new port here. And now, as you guys can see, if I click in this output, I have a list with my 3 points. Then I'm gonna get this output and connect in the NURBS curve. This is better, this is easier for us to understand what's happening in definition. And we can get a more clear view of our data flowing through the definition. Okay, so this is our first curve. Okay, if we change a couple of these parameters, for example, if I change this z value to 10, then our curve is going to be different, since this is all parametric. We can add more points. There's no problem with that. For example, I can just copy these three components here. I'll be changing the values here, for example, 3. And then I can add this point to our list merge. Again, we click in these inputs, we add a port, then we go here. Now we get like another point, okay? And for this node here, we got some options. For example, we got the Boolean, okay? This Boolean option is that we can create the curve periodically, so it will be going back to the first point. As you guys can see, they go from this point to the first one. That's not what we want. We want the open curve. And then we got the degree of this curve. So if I use the number constant here, yeah, and then I put the number 1 in the degree, we'll get like a polyline. If I put the number 2, we'll be interpolated this curve, a more smoothed curve. And then we can go more numbers. There is a limit also, but between 3 and 2, it works for us in this workshop, okay? So I'll be leaving this node here just so we can see that this is like an input. Okay, so all of this is just for us to create like a curve. But there's a easier and fast option way actually to create a curve here in BeeGraphy. We can use the curve editor node. This curve editor, it's a really straightforward node. We just load here in the canvas, and then as you guys can see, we already have like a curve here in our 3D viewer. If I change these handles here, I can like I can change my curve, the shape, all of it. I can import some curves also. There's this possibility. So it's a really more forward way of how we can do this. The only thing that we need to do is to change the size of this curve because it's huge right now. So first of all, we can like just determine which the shape of the curve that we'll be using, okay? And then what we'll be doing, we need to change the size of these curves. We can change actually the size of these curves using these two inputs here. I believe so. The guys from BeeGraphy, they can like confirm this, but this is like the area for this black box here. So the width will be like 100 and the height will be 225. And the way that I change these two inputs, I get like a smaller area for where I can like draw this curve. So let me check my inputs here. The y determines how long the length of this curve. So it's like 20. So for the width, I'll be putting like 20. And for the heights, I'll be leaving as 15 or something. Okay, so as you can see, now we have like this curve here, but it's not oriented in the way that we need. It's in the ground. We need it to be in the Y and Z plane. There's no problem with that. We can just rotate or orient this geometry to be in the same plane as this first curve here. So I'll be using the orient node, this one, and what the orient does. So imagine that we have like a plane here, which is in the X and Y plane. It's a surface. in the XY plane. And I want to orient it in another plane. Okay, I want to take this surface and then I want to like put it in the other orientation in another plane, not necessarily in the planes from our axis. So the orient asks for a geometry, a base plane, which is this one in this case, and then we can like orient it for another target plane. So I can get, for example, this surface here, and then I can orient like in this plane. For example, a plane such as this one, Z and Y, or something like this, okay? So what we need like the geometry that we want to orient. So I'll be grabbing this curve that we created. Then we need like the first plane, the source plane, where this line, which is the plane of this curve. Okay, we already know that it's in our ground, which is X and Y plane. So I'll be grabbing the plane XY node, and I'll be saying for this node that this is our source plane. And then for the third input is the target plane, where I want to orient this curve. I can use also the Y and Z plane node, because it's this plane that we are working here, where we created our curve. So I'll be putting right here. And as you guys can see, I have this first curve here in the XY plane, and I orient it to be in the Y and Z plane. Okay, now it's lined up everything. The only thing that we need to do is to move this curve to be in this right side of this curve. So it's an easy task. We just need the move node, and we'll be needing the motion vector, which is the direction that we want to move this object. Okay, we know we need to move it from the X axis, so I'll be grabbing the vector X node. And if I just pick this output and then put in the move, and then if I grab this output, geometry output, and then connect in the move, then you guys can see that we are moving this object here to this position. The only thing is that we need to input like another number here to make it move to the right side of our first curve here. Or alternatively, we can just change this X, this number here, which represents the X coordinate for our points. So for example, if I change here to 5, then we grab our curve, and then we are like moving all of these points to this coordinate in the X direction. We can do like in the both options. There is no problem with that. But I'll be moving it a little further, so just so we can see like how we can just a different way to do it. You guys can change it in any way that you want. As I said, you can change this value, or you guys can like add another number constant here. That's what I'll be doing. Number constant. Well, if I put this number 0 here, it won't move at all. But if I change this number for like 20, then we move like this curve here to this position. Okay, there's a lot of things here in my 3D viewer. I'll be hiding some of this stuff. For example, this curve, I don't want to see it anymore. The orient, I don't want to see anymore. Both of these planes, I don't want to see it anymore. The vector here, yeah, I don't want to see it anymore. I just want to see this curve. And also there's these points here, which I'll be also turning off the 2D here in our viewport. And there's some adjustment that we need to do, which is the size of these curves. So maybe if we can change this number to 15, this one's to 10, okay, it's already better. The only thing is that we need to change, or we can move this curve more through the y-axis, so we can align them to be in the same, I mean, just to be aligned, the two curves here. So we can like move it again. I'm gonna copy everything here. The only thing is that we want to move in the y direction. So I'm gonna put here the vector y. I'll be deleting this node. I'll be connecting this here. And I want to move this curve here. Okay, we move like a lot. I'm gonna change this number to 5 or something. Let me see. Maybe a little bit more, 6. Well, okay. I'm gonna hide this curve. And now we have our two curves here for our surface. Again, we can like change these control points here, so we can create like another design for our surface that we'll be creating shortly, and also changing all of the points coordinates, so we can change the shape of this curve here. So there is like these two options of how we can create this base curves for our surface. As I said, this one it's a little bit longer. We need to create all of the points, and then we need to interpolate the curve. This one we already had like a node for creating the curve. The only thing is that we need to change the plane. But in the end, it's same stuff. Okay, so our first curve is here. I'll be dragging it to be closer to our loft. Here we got the output for our move component. I'll be using a relay just so I can move it here, so I don't move all of the node. And then we can create like a loft surface. So again, I'll be merging these two lists here. This first one, then I'll be adding also the second one, and then I'll be creating a loft with these two curves. And as you guys can see, now we have the surface here. Okay, our first step is done. Okay, we already have our surface. And as you guys can imagine, everything is parametric. If I change the shape of this curve, my surface will also change. If I change one of these coordinates here, my surface will also change. Okay, just so you guys don't worry about this, I prefer first I create the whole definition, the whole stuff. Then at the end, I'll be grouping them, creating the names for the inputs and all of that. I believe it's easier for me, for my design process, just to create everything. It's like a mess in the process. Then we go on and start to get things all organized, all grouped, and all of that. Okay, so we have our surface here. Something like this. Okay, our surface. Okay, so what we need to do now? This is like the shape that we'll be creating our waffle structure. Now we need to create our beams, basically. We need to create them in the two directions. This direction here and also this direction here. This is like our second step, and it's like a really easy one because we have a node that can do this like really easy. If we'll be doing like the intersection for each plane, for each curve, and then we need to determine the distance for it will be like a headache. But we have a component that can do this. It's called contour. Okay, this contour, it simply take like any object and then start to creating this contours for our object. I believe you guys already know about this node, okay? But that's what we'll be using to create our guidelines for our waffle structure. So what the node needs? It needs a shape, of course. We'll be using our surface here. As you guys can see, it already starts to create some contours in our object, but the plane, it's not the one that comes here for default. It's the XY. The XY, it's basically our ground here. We need to change this plane to our Y and Z plane, this one. So again, if I take the plane XY node, oh, sorry, YZ plane, this one, and then I connect this plane here, you guys can see that we're starting to get these contours for our object. And also we had our distance here, which is the distance between each one of this contour. For this, I'll be using the range input. Okay, the range input, it's a slider where I can set the minimum value and the max value, and then I can change it just by clicking it and dragging it. So I'll be using 1 to 10, I believe. Yeah, 1 to 10, it's fine. Okay, and the step I'll be using 1. So now I have a slider that goes from 1 to 10, and each step adds like one number. If I change this to like 0.1, then I have these numbers are more like precise numbers, as I say. But let's stick with just 1, okay? We can change it later. So now I can take this output and then plug it right here. As you guys can see, if I change this value, I get like a wider contour in this object, or a smaller one, a more tight fit one. I'll be setting this one for the 2, okay? It's fine for now. And I want my definition to be fast in this when we are like creating it. I'll be hiding this node just so we can have our curves here. So this is one direction, right? It's the X direction. I need the ones in the other direction, in the Y direction. What we'll be doing, the same stuff here. I'll be copying this node. The only difference is that I'll be changing the plane. This one, it's YZ. I want now the XZ plane. If I plug this plane here, then I have my contours in the other direction. There's a thing here that, as you guys can see, there's some lines that don't go like all the way into our surface. The problem is, as you guys can see, our curves are not lined up the same ends like here, and I believe also in here. That's fine, since everything is parametric. We can just take this curve here, and then we can like push it to be a little bit more aligned, this endpoint here, and also this other endpoint here. Go on, go on.
Yeah, sorry. I have a question.
Yeah.
Why instead of moving your control point, you constrain your planes in the edges of your curves? I mean, the vertices of your curves, you constrain the planes there so that you have an exact division of your plane instead of moving the point randomly.
No, yeah, we can do that, but I want to be more free in our object, you know? I can create like really line up all of the control points here, and then we get like in the top view, we get like a box, basically like a rectangle. But I want to create it like a more complex stuff, you know? I don't want exactly to all of these contours goes to the end, you know? I want some of the beams go further in the connections, you know? It's more like a free surface here, a free structure, you know. But yeah, you can constrain all of these points to be like in the exact coordinates where they end up, you know. Okay, so I mean, this is like what I want, you know. This could be like a design option, you know. I don't want to my beans they go like and then in this other being the other direction. I want them to go further, you know, to create something cool. I don't know. And for this one, I need also to take it like a little further here. So we go back here, then I can like push it right here. And then maybe I need also to push this one like here. I mean, this looks cool, you know? This could work. I don't know. 20, 21, 20, oops, 25, 24, 23, maybe something like this. Yeah, sure. Okay. So we got these curves in these two directions here. Okay. We have this one, like a really small one here. We can get rid of it like really easy. There's no problem with that. But I want to continue further with this design. So what will be, we already have the curves in these two directions, which is cool, which is awesome. And again, as you guys saw it, it's totally parametric. You guys can create any shape that you want. But for now, let's start to creating this structure. So since we had now these curves here in the two directions, I want to give like a height for this object. So this is our curve. Now I want to create like the beam. I want to create like a height for this object, for all of them. So what we'll be doing, we can simply extrude this curve. So this is my output for the curves in the X direction. I can simply get these curves. I can put it in the extrude. And as you guys can see, we are starting to have like the surface, the area of these beams. But the problem is it's going up now. We need to go down here in our surface. So I'll be using, again, the vector z here. Okay. But the thing is, we need to make it this number negative because we want to go downwards. So I'll be using the range input, again, the same one that we use here for our distance. I'll be setting it to 0 to 10. We can use this step. Actually, 10, no, I'll be using like 2 as smaller value. Then I'll be using this step, 0.1. Okay. If I connect this output here, we can now determine which is the height of our beams. But the thing is, I want them to go downwards. So I need to grab this number and then make it negative. We can use it the opposite note, which is take a number and makes it negative. Simple as that. And now, as you guys can see, it goes down. We can also just do a multiplication of this number by -1. It's the same stuff, okay? So now we have like our beams in this direction. I'll be doing the same stuff here, okay, in the other direction. So I'll be also copying this node here, and I'll be connecting this one right now. I'm gonna hide these lines here. And as you guys can see, we have our surface, which indicates where our connections, where our beams are going to be. Okay, so just for the sake of visualization, we can simply offset these objects, then we can create like a width for them, and then it's done. But I want to take a step further. I want to create the connections for these objects. So, as you guys can imagine, looking in the front view, okay, I got this beam right here. And I also will have the beam in the other direction, something like this. I don't know how we can like solve these joints for each one of these beams. We can do something like this. I got one beam in this direction here, and I have this one in this other direction here. Where both of them they touches itself, where they intersect them, we'll be creating like an opening here for each one of these beams. So if we look in this view, we have for this beam something like this, and for the other one the same stuff but in the other direction. Then we can connect both of these objects together. So how we'll be doing this? And now it's like the last step of our workshop, and we'll be doing a lot of stuff here. So we got our surface here. We need to do, first of all, we need to have this intersection right here between these two objects. So what I'll be doing here, this is a workaround, okay, of how we can like find these intersections here. I'll be using here in the tool tab, in the intersection, I'll be using this intersect, surface, and curve. Okay. So this node finds the intersection between a curve going through or intersecting through a surface. We already have this both inputs here. We have our surface, which we can like connect here, and we have our curves here. The only thing is that we need to calculate this intersection for the curves in the other direction. So I'll be using, let me make space here. Let me move things here. Okay, so this is our surface, and then we need to connect these curves here into our input curve. But there's a problem here, and it's a data manipulation problem. we need to calculate for each one of the surface all the possible connections with the curves in the other direction. So the thing is, let me go back here. Looking at our list, okay, we have a list here, which is our surface that we extruded, okay? So we got one surface and all of them right here. And we also have the curves in our other direction, curves, and all of them here. Since we need to check for each intersection of the surface for each one of the curves in our list. So we basically need to do this. We are going to grab our first surface here, this one, and we are going to check for all of the curves that we have available in the other direction. But we need to do this with our whole surface list. So how we can solve this problem? Simply grafting one of these lists. I'll be grafting our contour list. So I'll be using the graft tree here. And then I'm gonna take our curves. I'm gonna put in this input here. And then I'm gonna plug it here. So as you guys can see, now we have our connections, but there is another problem here. In the way that we've done this, searching for the intersection between all of our surface with our lines, there's some points where we can't find some intersections. For example, here in the middle. And the thing is, there's a couple reasons of why this happens, and I believe it's a little bit related to the tolerance of the file, okay? I believe that we can change this here in BeeGraphy, but the workaround is really, really, really simple. We need to make like a brute force so we can find these intersections. Right now, we have like a surface here, and we have like a curve going on here. The thing is, this distance, it's like really small, really, really, really small, and they don't necessarily intersect with each one. We'll be just moving this curve here downwards by half of the height of our beams. So we are going to make it go like in the middle of them, then we can find the intersection for each one of our beams here. So what we'll be doing, just take this list, I'll be moving it, this geometry, I'll be moving in Z negative because it's downwards, and it's exactly half of this value here. This value indicates the height for each one of our beams. So I'll be copying these two of them because, again, we want the number to be negative and downwards, so Z. And I'll be adding a division component here. So I'll be grabbing this number, and I want to divide it by 2. If I just put the number 2 here, it will appear the number constant, and the input will be 2 when you load the node. So 0.7 divided by 2, it's 0.35. And now this is the number that I want to move my object here, my curves. So this is our vector. As you guys can see, now it moved like exactly in the middle of our surface. And now I'll be connecting this one here. And as you guys can see, we have all of the intersection points between our beams, okay? Let me hide some of stuff here. I'll be hiding this here. Our contours, we can hide them for now. This one, actually no, I'll be leaving this one. There's no problem. Here, here, okay. Okay, so now we have this point of intersection, okay, where both of our beams in the two directions are intersecting. Now we just need to create like the opening here for each one of our surface, okay? And we can do this in a lot of ways, okay? I'll be trying to do one that I didn't try in my original file, so I'll be trying right now. So if anything goes wrong, the guys in BeeGraphy can help me. So basically, we have like a beam here. We have another one here. I have my intersection point here. I'll be creating like a simple line going upwards. Then I'll be creating like a pipe object here. A pipe, just a pipe. And then I'm gonna create like a subtraction between this surface and this object. Then we will have our opening here. If this doesn't work, there's no problem. We can go in the way that I done in my other file. So this is my point. I believe that we can create a line starting at this point. We can use the line SDL. SDL goes from start, direction, and length. So the start of my line will be here. The vector, there is already one, as you guys can see, but I want them to go up. So it's the vector Z. And the length, we don't need to be this higher. We can put like, I don't know, 1. That can work. Or you guys can do this more efficiently, and you can grab this value here, which is the height of our beams, and then we can like put it here. So it always be like going through all of our height here, okay? But I'll be leaving number 1 for now. It's fine, okay? And then I'll be creating a pipe here with this curve. The pipe only needs a curve, a base curve, right? We already created, but our radius, it's like really big now. So I'll be using a range input so I can determine which is the opening for my object, which is the radius of this pipe. So minimum, I'll be putting like 0.1. The max, I'll be putting like 1. The step, it's fine here. Then I'm going to connect this one here. And as you guys can see, now we have a pipe here in our 3D. The only thing is that for us to subtract this pipe from this surface, we need the object to be like close. So I'll be using a cap just to close this pipe. Now it's like a solid. Okay, this is like a surface. Now this is like a solid. Okay, this is important. So now I'll be subtracting this pipe from this surface. I'll be using the Boolean operations tab, and I'll be using surface difference. So what it needs, the two geometries, one that will be subtracted and the one that will subtract this object. So, okay, let's see what happens. This one here in my extrude curve here, I'll be using as the object that I'll be subtracting, and this one will be the object that I want to subtract. But let's just me check one thing here in my file. I'll be using a flattened tree here because now we have like a data tree here. I'll be flattening this tree. I just want a list with all of my objects here. And just to be safe, since Boolean operations They are really like slow operations depending in the objects. I'll be changing my counter here. I'll be putting like 5. Okay, it's like a more wider object, just so we can like see what happens if there's a bug or something, just to be safe. Okay, okay. So let me hide this here. Let me hide this here. And I mean, everything here. And as you guys can see, now we have an opening in our object, right? What we need to do now is to make the same step for the other direction. Okay, the same stuff. We can use this definition here, this snippet right here. I'll be copying this snippet. The only difference is that in the line SDL, I want to make it like negative because I want this line to go downwards. So I'll be using the vector Z. I'll be using the opposite. And I believe I can't put like a vector here. Yeah, I can put it, but there's no problem. I just be using like a number constant here, number 1. Now this is like -1, and this is my vector right now. Since this input in line SDL, the vector that can be in like any side that you guys want. I'm just creating like a -1 input for this vector, just so BeeGraphy can understand that this is going downwards. Okay? So this is my lines, this is my pipe, and just so we can make this easier, I'll be using the same range input here for also in this pipe, since they need to be in the same width. Here is my pipes. Now I will be using again surface difference here, and I'll be using this surface here from my extrude curve in the other direction here, and I'll be subtracting with this object here. Okay, let me hide everything here. Ooh, and we went through something here, something unexpected. I'll be using the same vector here, and let's see if we got like an output. Yeah, okay. So the thing is, I'll be using the same vector here, so it's going upwards. Let me just hide this so you guys can see. The line is going upwards, but I'll be like moving downwards in the other direction. So again, I'll be using the move, this one. The vector will be the Z vector right here. And I'll be moving this number here. So opposite, here, here. Okay, let's see what happens now. Oh yeah, that's it. Awesome. Yeah, maybe it's like a geometry direction or some stuff, you know, because I just created like upwards and then I moved like downwards and then it's out, you know. But that's what I was expecting. Okay, so now we have like an opening in the other direction. And as you guys can see, now we can like connect everything here. Okay, so let us see what happens if I grab this here and I put the number 1. And now let's wait. And just to be fair, it's Boolean operations. It's for any software, you know, it's really hard for computers to do this. And with a lot of geometries also. If there is like, if the editor freezes, like we can open like in safe mode and then change this input. But just so we can see what will happen.
What was the other approach that you did before?
Oh, we can create boxes. You know, it's the same stuff, but we create like a box here. You know, but we will have to input like the height, the width, and all of that. And there was like a couple calculations that we have to done. But with the pipe, it's easier, you know, because if we see like in this view, the pipe, it's like a square, you know, so it will be easier and more straightforward, you know.
So now it will be like more dense. You have more
Yeah,
waffles.
yeah, much more dense. I already did a like a test yesterday, and it runs, you know, it can create like everything and create all of the connections. But again, as I said, Boolean operations, it's really hard for computers, you know, to do all of this.
How long did you have to wait?
No, couple of minutes or something, you know. But since I don't want to take this workshop further, you know, I'm opening the file again in safe mode. Okay, so guys, I open it here in another tab, the file. Okay, in safe mode, so the solver, it's like logged, and then I'm just gonna change this value to 5 as we had previously. I'm gonna run the solver, and it's expected to, we have our definition here. Let's try with 4. I don't know, let's not go so much denser. Okay, 4. Okay, let's try 3 for now. Okay, fine. 3. It works. Yeah, we can use the number 3. So let me just dock this here. This here, well, goodbye. I'll be using now this one. Okay. Okay, let me just see. Okay. So now we have our pins here, and we have the opening, as I mentioned. Let's just create like a 3D for this, just so we can like finish this workshop. Okay, so we have the node offset surface, okay? And it works as you guys expect. I put like my offset here, and then it offsets my geometry. For example, let me put the distance 0.1 or something. Okay, this one. So as you guys can see now, my surface is offsetted. But the problem is this is not a solid, right? We can offset for now surface, and we can create like a solid, as what I understand about BeeGraphy. But there's no problem with that. Let's just delete both of these nodes, and I'll be showing you guys how we can create like offset and make it solid in the end. So or since this is like in the middle, in the axis of our contour, we need to like move this object from a little bit to the right and for the left in this axis here, which is my x-axis. So what can we do? We can extract the contour of this object with the BeeGraph, surface by edges, because we are using a surface edge, just one. So I connect a surface here. Then, as you guys can see, we got edges of the surface. Then we just need to move it like in these two directions here. So I'll be moving these edges here, this one here, in the x-axis. So I'll be using the vector x. And now that's important because we need to move exactly the radius that we set up here, because this indicates of how thick our beam is. Okay, so we need this number right here. Someone raised their hand. Go on.
Yeah, sorry. Instead of doing that, I think it's laborious to have to offset the curves. There's no option to just thicken the surface and get this solid.
I believe
you have to offset the curves to necessarily have the thickness.
I mean, sorry, can you repeat? Sorry.
I said there's no option of putting a thickness to a surface to make it solid. Instead of offsetting the curves to create the solid, you just thicken the surface you have. You put a sort of shell modifier of thickness. I don't know what.
No, yeah, I believe I understand what you are asking, but learning can back me up in this one. I believe there is not a component right now which we can like offset the surface and create solid, right?
We can use, I think, extrude surface for this.
Yeah, the thing is, the extrude surface, we are going to only extrude the surface from one side, and then we'll be needing to offset it to the other side. Then we'll have like two solids, and then we'll have to like join them. And
so it's not like grasshopper, which extrudes on both sides. Yes,
I don't know.
And grasshopper extrudes on both sides.
We have an option like here.
And the another option could be probably we can move the surface by half, let's say half units.
Yeah, we can do that. Yeah, we can do that. We can move it like half of our opening, and then
just
we can
like the vector.
like yeah. That's a good option. That's why
there's actually also a node called side thickness. So you can give it a surface that,
it is that.
but I actually can't remember whether it thickens on both sides.
Let's try. We are here. Let's try. Okay, so this is the surface. Okay, yeah, we can create. Yeah, we can like move half of our opening, and then we can create like this thickness to get like the full width. Let's try that. Let's try that. So let me just disable this for now. So we need to move this geometry. We are going to move it like in the vector X. I want to move it to the left side, so I'll be using this one. I'll be already getting the opposite node here. And we need to move half of our opening size here that we determined for the pipe. So let me use the relay. I'll be grabbing this information here, and I'll be using the division. So I can get this number divided by 2. And let's use this. So we moved like half of our distance. Now let's use the side thickness here. Let's enable it. And now we need to have a thickness of the full size that we determined like here. And that's it. Yeah, nice. That's why I like to teach, because there is a lot of logic that we can like talk and then we can share, you know. For sure, this is like a much simpler solution, you know. But that's why I like to be teaching, and everyone can share their thoughts and so. Okay, the thing is now we need to do the exact same stuff in the other direction, this one. So I'll be just I'll need like all of this actually. Yeah, I'll be just copying these components here. Okay. Let me disable this for now. And we are going to use this geometry that will be moving. The direction is y, vector y, positive, so we don't need this node here. Okay, okay. And for the thickness, yeah, that's it. Oh, no, sorry. So now there's a problem because site thickness only goes like in this direction. So I believe this, let us try the opposite. Here, let's try to input this number in the negative. Yeah, that's it. Hello, can you guys hear me?
Yeah, we can
Yeah,
hear you.
I was asking you guys a couple of questions. And I just realized that there is like a kind of error here. Since we determined like the pipe, it's the radius. So 0.1, actually diameter, it's 0.2, right? So we'll be needing to multiply this value here by 2. So I'll be using multiplication here. I'll be using the number 2 here. And then we are going to use this for the side thickness. And I can use the same one like here. Okay, as you guys can see, now we have like this 3D. And the connection between these two objects here. Okay, there is a lot of stuff here that I'll be like hiding it here, I'll be hiding. And there is like a couple of things here, a couple of bugs, I may say, in this code. For example, this one here, this small beam here, that we don't need it. Okay, so how we can like remove this object here? We have to go all over here in our contours, just the lines, and we'll be needing to create like a condition here. And the condition is related to the length of these contours, okay? Because let me hide all of this. As you guys can see, we have these contours that goes all the way through our surface, and this one which is really small. We can create like a logic that each contour that it's like below the average distance, we can remove it. Go on, Florenza.
Yeah, sorry, I was just asking, instead of just going back to the code to see how you can remove that, it's not possible that at the end of what you have done, you just drop it. I mean, like list or remove something and you drop it out of the list.
Yeah.
Going back to the code.
Yeah, you can do that, but we need to think in the way of how we can optimize this definition, because we can do all of that. We can find the intersection and all of that, and then yes, we can like remove this last being here. But do you agree with me that there is no reason why we need to be creating like a solid here and find the intersection with this geometry here, since they will be like removed in the end? So we do this like in the start. So we don't lose like computational time, and then we calculate all of these stuff for a geometry that we don't need it. Okay? So it's like a small optimization that we can do in this code to room like a little bit smoother. Okay, so yeah, we can do that in the end, but we need to think like in the logic of this code and to make it run smoother. So what we'll be doing, okay, I got all of my contours here. I can calculate the length of these curves with the curve length node. Okay, and I'm gonna grab a panel here just so we can like see. And as you can see, we got all of these lengths here in our panel. And then there's like one which is like really small. All of them goes through 10, and then one that is 2.6, which I believe is this one, right? You guys can see that. So what I'll be doing, I'll be calculating the average numbers of this list. Okay, with this component, I know that every it's 8.8. Fine. So now what I want to do, I want to remove all of the lines here that it's below my average. Okay, so what I can do, I can check which value is smaller than our average. So here in my list, my length list for all of my curves, and I want to check which one of these values is smaller than my average, 8.8. So I'll be connecting this one here, which is the numbers that I'm testing, and this one I'll be connecting here, which is the number that it's being, sorry, this one is the numbers that are being tested, and this is the one that I'll test with. And now we have our booleans, which indicates which number in my list, again, this is my number list, it's smaller than my average. And as we can see, this one is true, because 2.6 is smaller than 9.8. What we need to do now, we need to split this list, and we can use the dispatch list. What the dispatch list does, it takes a list and the Boolean pattern, which is exactly this output here. So here are my contours, and this is my Boolean list. And now I have my output list A and list B. I'll be using a relay here so you guys can see. This one is my small, tiny contour, and the list B are my larger, bigger contours. And now I'll be using these outputs in my definition. So for now, I'll be locking my solver, and I'll be connecting now this list here and this list over here. I'll be enabling my solver. Let it think. And now we should have, let me see here. Oh yeah, these ones and these ones. So as you guys can see, we don't have like that tiny one anymore. And just so I can go back to the Florenza question, we don't need to calculate all of we've done here with that tiny one. Okay, we just calculate with the ones that we want. Okay, let it hide here. So for now, it's fine. Okay. What I want to do with you guys is how we can like export this for some file, DXF or something, so we can like laser cut it and do some stuff with it. The first thing is that in our surface here, they are like in two different planes, you know, so we can export this to a DXF file, then we can like laser cut it. We need to move it to the floor. We can make it like, we can need to orient it in the plane that our machines will be using. So I'll be doing exactly what I've done with that older curve, with our first curve, actually, the one that we did here, that we oriented our geometry. So what I'll be doing, I'll be taking simply these objects here, and I'll be using orient. Okay, so the other thing that we need to do is that we need the plane for each one of the surface. Let me try something here. No, it doesn't accept. Okay, so we really need to extract these planes from this surface. I believe we can use the centroid for this one. Let me check. Okay, so we got a centroid of our geometries, right? And for this one, we have like our points here, and I'll be creating a plane, sorry, in the X and Z direction. So I'll be using the plane XZ. I'll be putting this bounding box, this output here, which are our points, okay? And this one will be the reference, the source plane for our geometries. Be connecting here. And the final plane, just to make it like quicker, I'll be using the plane XY, which is our ground, okay? I'll be connecting here. And as you guys can see, we have all of our geometries here, okay, oriented. I'll be using now the surface edges here, just so we can like output our edges right here. We can do the same stuff, okay, exactly the same stuff for our surface in the other direction. So I'll be copying this code snippet here. And I'll just be reconnecting this one here, which is the centroid, the geometry. The plane is not anymore the XY. Sorry, the XZ, this one. Now it's in the other direction. So it's YZ plane here. I'll be connecting here. Okay. Now the geometry, it's oriented in the same plane. Just so we can see, I'll be moving all of these objects a little bit further upwards. So again, I'll be using the move. It's easier this way. I'll be using the vector Y. And it's fine for now. Okay, now I have all the lines in this direction and in the other direction. So what we can do? We can use now the exporter, and we can use like STL. Okay, I can grab all of this geometry. I can put it like right here. Okay, and how this works, we will be exporting this in the editor. Okay, so let me copy this one here.
You can connect all of them to one.
All of them in just one?
Yeah.
Oh, yeah, okay. We can do that. Sometimes I just want to be like safe with it, so I connect like a lot of outputs. So if it works in this way, it's fine, right? Okay, so we can go through our demo, I believe, right? And we can see all of this working in the editor. Okay. Okay, maybe I just... Oh yeah, okay, I just turned it off like the viewer here. Okay, let me just refresh this. So that's it. I just want to download the files because I want to show you guys another thing that we can do. To guys is that since BeeGraphy doesn't have like a nesting plugin yet, I can say that yet, we can use like an open source software that creates nesting, which is the deepen. And it's a really good alternative if you don't have like any nesting software like RhinoCam or OpenNest or anything at all. This one is like a really simple software that you can just download it. You import your DXF file, SVG, or even Coral, and then it creates like a nesting for you guys. So you just like import the file. You select which one is your sheet to be, which will be, all the geometries will be like nested. And then at the end, they create this nesting. And it also gives you like a lot of options that you can choose for the nesting and stuff, and give you like a form here telling you how much sheet you use. If you have all of the parts that you choose to be nested, it's in the nesting, how much time it took. It's really like a handful to have if you don't have any of it. So with this workshop, when you export all of these lines and curves and all of our structure, you can like load here in this software, and then you can create like the nesting, and it's free, so which is like really nice. It's open source. If you guys know anything about scripting and all of that, you guys can also mess with the project, you know. So it's like a really good alternative. I use it like a couple of times for some projects, and I really recommend. Let me refresh this page. But everyone, this is our workshop. We are in the end. If you guys have any questions or any comments, you can go on. But for now, I can only say thank you for everyone that's here, and for the guys at the BeeGraphy for the invitation. Okay, and again, I think BeeGraphy, it's like a really handful tool. You know, I've been like really enjoying it, using it, and creating some stuff here. I think it makes sharing all of this logic and all of these parametric models in the web really easier, and how we can share with other people, how we can use the editor, how we can, anyways, everything, you know. So yeah, I'm really excited for what BeeGraphy will be doing the next months. You know, I'll be for sure checking it. And for now, that's what I can give you guys. That's what I can share for my experience here with the platform.